Hello guys, so my graphics card died 6 weeks ago and I was not able to upload this video. The files were in limbo, but basically I came across this startup or young company based in Israel who do smart contracts in a dependently typed language, among other things. And was able to arrange an interview with them, and uh, I'm back making videos and hope you enjoy this as much as I did. Hello boys and girls, this is going to be another video on blockchain related stuff. Namely, I found a startup or company who is kind of at the intersection of topics that I discussed on this channel before. I'm going to start the interview in about 10 minutes, so I can do a pre-introduction. I found these guys by watching a YouTube video where they were also kind of interviewed and on the side mentioned that they were using dependent types, and so I reached out to them and managed to get this interview. I hope that I don't diverge too much from the standard content of this channel. On the other side, I have a lot of general questions for them that they like about blockchain and cryptocurrencies that they have much more insight, certainly, than I do. So this is going to be a little broader than what we do else here. So enjoy. I see. Okay, so I guess we're at half an hour now here. Since at the beginning this didn't quite work, would you like to reintroduce yourself again? Like, let's do a we are so and so and we do so and so again, so that I can use this kind of video which kind of works a little better. If you could just repeat that. And
Sure. So I'm Asher Manning. I work mostly on the smart contracting language and formal verification at Zen. I have a background in mathematics and yes, that's it.
Alright, I'm Nathan Cook. I am the CTO at Zen. I'm responsible for the architecture and all that stuff. I'm also from a mathematics background, as well as Ash. I have been in Israel for a while. I've been in Bitcoin for a while. I'm interested in decentralized platforms, and that's about it.
okay. So as far as I understand, your startup, as compared to, let's say, many ICOs, you sit on top of the Bitcoin blockchain, right?
Well, next to the Bitcoin blockchain.
Yeah.
I give you a comparison. You got Rootstock. On Rootstock, you send money, you send Bitcoins to a group of people.
Okay.
And they give you Rootstock tokens on their chain. Then when you want to get your Bitcoins back, you send Rootstock tokens back, and they give you Bitcoins again. But their chain is on top of Bitcoin.
Mm-hmm.
Our chain is next to Bitcoin. So if you're on our chain, you can see what Bitcoin is doing.
Okay, so you do have a chain. You do have a chain protocol where you access the transaction data that's kind of streamed, or
yeah, you can. Our protocol understands Bitcoin's own blocks and its own transactions. And miners on our chain, they can put in a reference to what's going on in Bitcoin.
Mm-hmm.
That's how the data from Bitcoin gets into our chain. And that means that you can have things that in Zen that depend on things that happen in Bitcoin. So if I want to sell you something on Zen, I don't have to sell it you for things in Zen. I can also sell it you for something for Bitcoins.
Mm-hmm. Yeah, I get it. So Because your smart contracts can observe what's going on the Bitcoin blockchain. You can make that part of the contract, I guess, right?
Absolutely, yeah. The state of the Bitcoin blockchain is available, accessible to contracts.
Yeah.
So that gets us like one direction. I mean, you can take value from Bitcoin and you can kind of move it onto our chain if you want. You can say, if I do something on Bitcoin, it means that I get assets.
Mm-hmm.
Yeah. And the other direction is harder. And we've got a couple of ideas for that. But that's gonna take some more time.
And
is that we get a real link in both directions between like Bitcoin to Zen and Zen to Bitcoin, and then you can move Bitcoins back and forth.
Okay.
But it'll still be Zen will still be its own chain with its own proof of work, its own security.
So you would take some kind of Bitcoin API and move stuff in terms of Bitcoin. Is that the idea?
There's no real support for it in Bitcoin right now. So our Zen protocol, everyone who runs as a compatible client in Zen protocol has to have a Bitcoin client too. That's if they're doing like full security. Mm-hmm. And then they can see everything that goes on in the Bitcoin blockchain. But going in a different direction and having things in Bitcoin depending on things that happen in Zen, that's going to have to wait for a while. That's called sidechains, two-way sidechains, and that's going to depend on what Bitcoin does, maybe in the next year or so.
And who else is doing this kind of stuff? Who are your competitors, so to speak?
You've got Rootstock, which is doing a federated peg. So there's a group of companies that let you move Bitcoins onto a smart contract platform and back again. Mm-hmm. You've got Ethereum, who are doing their own thing.
Right, they have their kind of own, like they don't rely on Bitcoin, or they're not about transactions on Bitcoin at all, right?
Correct. Yeah, what they've done is they've created their own currency, called Ether, and you use Ether in their platform, which is also for smart contracts. So it's all like a self-contained system in Ethereum. They don't care about anything. They don't care about Bitcoin or anything else. Rootstock is Ethereum's technology, like the Ethereum smart contract platform, but using Bitcoins instead of Ether. Uh-huh. Theoretically, right? That's what it's supposed to be.
And how did this idea come about to do it like the way you do? I mean, what happened in the 1 or 2 years before you get started with this company?
So we saw what happened with Ethereum being launched, and we saw people doing stuff on Ethereum, and we noticed that Ethereum was trying to do a lot with not enough. It was trying to do any sort of computer program at all. Yeah. And you'd run it in this big world computer, and then you'd do everything on top of that. You'd create any sort of asset on top of that by writing a program to make an asset, or to represent an asset. Or you'd write a program to do an exchange, or you'd write a program for anything. And we also saw that there were some very big security failures. So there was a massive loss of funds, and something called the DAO.
Yeah, right.
Motivation for us to think of something better.
Your perspective is that the Ethereum idea is too broad and brings too many tools that are not really used in the end, and so you specialize it down to focus more on the finance side proper.
Yeah, if you design something to do finance instead of just to be a computer, then you can be a lot more secure at doing finance.
Yeah.
Starting to lead into inside the computer science side of stuff. So that's one thing. The other thing is that using your own currency that you generate as like the unit of account for everything. It's like if you measure everything in something that you make on your own network, then that's not good. It means that your smart contracts are competing with your own money, and your money is competing with contracts. Yeah. So moving money around is more expensive, and doing smart contracts is also more expensive. With Bitcoin, you see that Bitcoin does have smart contracts, but they're not very complex ones. That they have to be very efficient. They can't compete with like Bitcoin's purpose of digital money. So we thought if we could create something, a smart contracts platform that was decentralized, that wasn't competing to be money, then we'd have a good product. That's what we try to do.
And so the reason why I found you is you use some interesting tech and programming languages.
Yeah.
What is the range of tools that you use? How does it look like in your day-to-day practice? And how did you get there? Why did you choose to use what you use?
So when designing a smart contracting platform, it's very important to have a strong language for writing these smart contracts. Now, a major influence in the creation of Zen protocol was watching what happened to Ethereum, the DAO. Mm-hmm. And again, more recently, a similar issue has emerged with multi-sig contracts with the parity multi-sig contract in Ethereum. When you're controlling assets, you need to be very secure. You need to be very sure that there aren't going to be bugs in your code that aren't going to misdirect your assets, that aren't going to delete any record of their existence, or you're not going to have smart contracts that fail halfway through. You're not going to be exposed to bugs in other people's code. Mm-hmm. So we decided that an important feature of something that controls assets would be that you're able to certify the correctness of a program. So we decided to use a dependently typed language, one that can express proofs on the same level as code, so that when you have a smart contract, you also have some kind of proof of what the smart contract is doing, and you can know in a very strong sense that you're not being exposed to bugs because you've implemented something that's slightly wrong. You can write a specification for what a smart contract is going to do. You can write how it does that, and you can check that it meets the specification. So to do that, we have a language that we've developed. It's, I suppose, a dialect or a variant of the F-star language developed by Microsoft Research and INRIA. It's an ML dialect with dependent types, more or less. Mm-hmm.
So I am interested in also, of course, in dependent types, in particular Idris. And I mean, I would have a lot of questions in this direction. For one, since I don't know many companies who actually use such sophisticated type systems yet, how much of the tools do you actually use in a day-to-day basis? Like, you know, features like product types, sun types, and how often, like, writing the formal proofs can be very like time consuming, right? So to what extent is the code that you're writing beyond what, for example, Haskell would be able to provide?
So with our smart contracting language, it'd be very common to use dependent types, existential types, quantified types, so that you can express proofs or even just to write regular code. With regards to the difficulty of writing proofs, the F-star language uses the Z3 theorem prover to automatically discharge most proof obligations. In practice, we found that most of the proofs that we're actually interested in can be done entirely automatically. Mm-hmm. When writing proofs, you can build them up out of smaller things. So you can write smaller lemmas, smaller bits of relevant information that can be done automatically, and then you can just combine them. So in practice, there's very little theorem proving going on. There's just thinking about which theorems you want to have, and maybe thinking about some smaller theorems that you could combine to make bigger theorems.
And how do you decide when you want to, you know, throw in the whole theorem proving gadgetry, and when you say, well, this piece of code is not so, you know, you're basically sure that it will work as it should, and so on. So again, to what extent do you need language or the language capabilities beyond what some other ML languages can provide to you? For example, I think I've seen people using OCaml for blockchain stuff, or the classic example would be Haskell. Like, what advantage, to what extent would you say, if I would do this in another functional language, then that would really be like a much worse case? Like,
Okay.
Well, in terms of developing libraries and I suppose trusted code, it's not as important, and you use more or less any language you want really to implement code that you trust. But the point is that when you're exchanging smart contracts, when you have assets being controlled by these things, this isn't necessarily trusted code, and you do need to be able to quickly verify their correctness.
mm-hmm.
You can't do that easily in a non-dependently typed language.
Yeah.
You can write programs that are very likely to be correct, but if you're trying to hide bugs or backdoors, it's still very much possible. You can't express any kind of check over the code that it does what it is supposed to do.
So do you also take it's other people's contracts and do some like run some checking of it using another software? Is that also the idea, to kind of verify to what you get, that it's actually secure?
No, so this is happening on the same level. So you have proofs in code, the same level, and as with any other dependently typed language, if any asserted property is not true, then compilation will fail.
Yeah. So what I'm asking is more like, do you do the proofs for yourself, or also to check other people's stuff, like the stuff that you kind of commit to?
So at the moment, we're only checking our own code. We haven't launched yet, so
yeah.
We don't really have anyone else's code to audit. There have been a lot of attempts to verify Ethereum code with various dependently typed languages. There was an interesting study in 2016 that used that articles, and they found numerous errors.
I imagine Solidity is kind of a mess, right? It seems like people need to invest a lot to learn it, and then they're still not sure if everything works out. I mean, I guess finance and these kind of crucial topics are, I mean, it's easy to sell dependent types there, because things are stricter and so. But are you not afraid that people would also have, kind of like with Solidity, to learn a new language to do your user software?
One of the issues with Ethereum is because they run a virtual machine, it has to have some kind of bytecode. Even if Ethereum were to decide, okay, we're using a dependently typed language, you're still going to compile it to bytecode and submit the bytecode. So there's nothing stopping someone from just writing Solidity again and compiling it to bytecode.
Mm-hmm.
People can always work at the lowest level that they choose to, and they probably will. If most developers are familiar with imperative untyped languages, that's what they're going to want. One of the reasons why you have to use the bytecode in Ethereum is because they don't know how long programs are going to take to execute before they run them.
Mm-hmm.
So they have to interpret bytecode and increment some counter of how many steps it's taken to execute.
Yeah, I read something to do with gas also, and so
That's the gas system. Now, you can avoid having a global virtual machine at all, and you can avoid having bytecode at all, and have a platform entirely defined by a high-level smart contracting language.
Yeah.
If and only if you're able to know how long things take to execute in advance. And then you can compile, and you can run with all the efficiency of compiled code, because you already know how long that compiled code is going to take to execute. Now, knowing how long the program will take to execute is something that can be accomplished with dependently typed languages.
Sorry, stupid question. So if you use a lazy language like Haskell, does that complicate things in this regard?
No, actually. If you're trying to find out how long something will take to execute, you more or less have to have lazy semantics, because otherwise people can do computations and discard the results. So there's no way of tracking where computations go unless you evaluate computations lazily, so that only computations that are being used are evaluated.
Okay, I have to be honest, this goes beyond my knowledge, and I lose the semantics here, but I see there is another argument for using like going the route you do, I guess. So was this all like when you started, when the company idea was started, was this already a selling point, or did this kind of evolve?
This kind of evolved, yeah. Our original the things we originally thought were important were to have a high-level language in which it was possible to write very clean, easy to understand, and easy to write secure code. We were also interested in knowing how long things would take to execute in advance. For that reason, so that we can not have to have a virtual machine, so that we can have smart contracts that aren't dependent on the state of the rest of the
I start to see the differences now with other ideas. As far as I understand, projects like Armchairs and Status, they use C#, right? So that would be a language that's much easier to learn, right? It's like a I don't want to insult anybody, but a Python-y Microsoft language. Do you see, like, I guess you would argue that's not as safe as F*, but of course they will have an advantage that there are like a billion C# coders already, right? And as I understand it, F* is an even smaller community than, let's say, Idris.
Yes, it's a small community. I will say that F*, because I'm not an expert in F*, this is the idea, the decision to use F* is very much motivated in conversations with Ash, but having seen F* is not that different from other conventional languages, from F#, say, which I use all the time, or from OCaml.
Yeah.
It's not that hard a language to use. And particularly with libraries that support smart contract programming, supporting the things that we do, that people do in smart contracts, it becomes like pleasant to work with.
With regards to users learning to use ML dialects in general, like F* is very similar to OCaml and F#, so it's more or less
okay. So
it's like with dependent types.
So you'd say it's like learning a dialect of something if you're already in the functional field. So the hurdle shouldn't be.
Languages like OCaml are useful because they're very easy to pick up for people who aren't familiar with them.
I have not tried it yet. Yeah, I have to say.
Very famously, Jane Street decided to use OCaml in their day-to-day operations because they thought it was a very easy language to introduce to traders.
Yeah.
Who have similar requirements to what we require because they're controlling assets with code. So they're a very interesting case study because they've shown that this can really work in practice. So we think the same will happen. If people want to be writing smart contracts, then they probably will take the time to learn how to use a language built for that. And most likely they'll appreciate it. I think most
I'm all for it. I think it's great that I see dependent types on a proper company side being used. So I've been following your announcements, and another topic that was coming up is oracles and porting information from the outside world to to smart contracts. So what is it that you provide there, and what are the problems in this regard?
Okay, so an oracle is, as we say, it's just something to bring data in from outside into a blockchain, and you kind of need that because a blockchain is a consensus mechanism. So if there's outside data, then that has to be consensus on that data. So you need a source of data that isn't inside a blockchain. That's what I'm up with. There are different solutions. Our solution is a pretty simple technically. The idea is that the data provider puts commitments, cryptographic commitments of data into the blockchain, and then sells access or proofs that match those commitments later on. And you can do that in such a way that the act of paying for the data and the act of giving the data to the person is the same thing. It happens both things happen, or neither happens. So that means that oracles can get paid. That's an advantage of what we're doing. If you look at other oracle systems that have been proposed, there's a big problem that once the data is there, once the data is in the blockchain, anyone can use it. Even people who didn't pay for it can use that data. Which means that the value to the person who's operating the oracle of having an oracle, it goes down because he can't be paid for what he's putting in there.
Can I to understand this correctly, that the person who is responsible is kind of the gatekeeper who gets something out of bringing data from the outside world?
Yeah, let's say as a user who wants to have a contract that's based on some outside data, you will find some oracles, more than one. You'll find 3 or 4 different people, maybe even more, and you will arrange to use their data. You'll set up your contract to use their data.
So it's a kind of marketplace in a way, a marketplace of data on the blockchain.
Absolutely. You will definitely see that sort of thing happening as a result of
that's interesting.
Because the idea is that having cross-checks, having more than one person commit to the same data is important, because it means that you don't rely on any single person. It's a kind of decentralization. You don't see any single person.
I have only seen on Ethereum like Hello World and basic token smart contracts. Can you tell me what kind of information can I actually use for a smart contract on this decentralized network? For example, if I want to make an app that tells me the weather in Vienna, okay, can I access this kind of data, or can I put sensory data and make it available in the network?
Any data you can just commit into the blockchain. One of the things is, it doesn't matter how much data you have. You can have gigabytes of data. If you only want to sell it in small pieces, then that's still efficient, because the commitment is small. The proof of the data is small. You don't have to reveal all of the data. But yeah, the weather, absolutely. There's no restrictions on what sort of data or the meaning of the data. It's up to the contracts to interpret the data in the way that they want to use it.
And this, it doesn't matter what data it is. Does that hold for all blockchains, or is it specific to what you do? I mean, on Ethereum, can I import data? Can I import I don't know, Amazon prices in Ethereum contracts?
There's, because of this problem with oracles not getting paid enough. We believe there's not been a lot of attempts to have oracle. Theoretically, yeah, you can have any sort of data.
Okay.
The issues are, is it efficient to put that data into the blockchain or not? If it's not efficient, then the data will be too expensive, either for the person buying it or for the person selling it. So that's the problem that we're solving with oracles. We're making oracles efficient, and we're making them economically viable.
Yeah, I get it, I guess. So I was thinking of, because like if I, as someone who's, I mean, interested in cryptocurrencies and blockchain a bit, but not really into it, if I were to make some decentralized application, like what I was asking, because I was thinking, what can I actually use to make you know, a program? Can I actually create something interesting there?
Yeah.
But as I understand from you that also you're working on solutions where you can use pretty much anything I would wish for personally.
Excellent.
Okay. So you are how many people in Zen Protocol?
There are 7 people right now.
Yeah. I have on your webpage. I've seen this photo behind this glass with the logo, and you're sitting there, right?
Yeah, right. Yeah, that's us. That room is just over there.
Yeah. And do you have your own office here, or is this a rented office space?
That's our office.
Okay.
That's our office.
So 7 people and
shared. This is shared working places, but it's split into offices.
I see.
It's pretty cool.
Okay, I was wondering because the conference room wasn't free if you're only 7 people and already so busy that you have conferences stacked up for every hour. And how many of you do actually do the coding of the protocol?
Let's say 4 or 5 of us.
So most actually.
Yeah.
And you're already F-star hackers?
Well, some of us are. Like Nathan and I have written a fair amount of F-star code.
Yeah.
There's much more to our platform than just the smart contracting language.
Yeah.
This is kind of divided up between us.
Yeah.
Mm-hmm. And so the protocol side is in what language? Like
it's mostly in F#. We have some network code in C#. Which is okay for network code. At some point, we'll want to take a review of what code we want to verify, we want to formally verify. Right now, we are focused on developing it. The verification is most important for the smart contracts themselves, for a couple of reasons. But because of that, we're focused on doing our smart contracts in F-star, showing it's possible.
Yeah.
We can talk about formally verifying other parts of our plan.
And do you hope to expand in terms of company size? Like, what is the field? What are you missing, so to speak?
Okay, so there's a lot more that we could do. Apart from validating other parts of our clients, there are other technical innovations that we can pursue. One thing is to proof carrying code, so that other contracts can understand the proofs.
Mm-hmm.
Which is something that could be very powerful and can enable small contracts to be a lot smarter. Let's say there's plenty we can do in infrastructure as well. Services that use our platform, use our decentralized platform, to do things like exchanges with decentralized escrow. So that no one actually controls the funds except the people who are trading. There's a lot of work to turn this into something that is industry standard. But what we've got right now is we have a proof of concept. We can demonstrate that you can do these things in the blockchain. You can have one of the verified contracts. You can show resource bound. You can show how long these contracts are going to take to consume. And you can have the sort of architecture. We haven't really discussed the architecture. We can have an architecture that is well suited to financial use cases.
And
so that's where we are right now, and that's where we want to.
Right, and so this month is like the takeoff month, right? In a way.
Yeah. So we're going to be raising some money. We've got a token sell. We are showing a lot more about what we're doing now.
Yeah.
Code examples, we'll have source code available. We're doing lots of interviews like this one. We are writing articles.
Right.
And we're showing what Zen is for.
And are you like, is the plan to work mostly globally, or do you have a preference to talk with people around Israel and locally?
No, we're perfectly happy to talk to anyone, anywhere in the world. Preferably in English. That's
I see. Okay, so I guess we're at half an hour now here. Since at the beginning this didn't quite work, would you like to reintroduce yourself again? Like, let's do we are so and so, and we do so and so again, so that I can use this kind of video, which kind of works a little better. If you could just repeat that. And
sure. So I'm Asher Manning. I work mostly on the smart contracting language and formal verification at Zen. I have a background in mathematics, and yeah, I suppose that's it.
All right. I'm Nathan Cook. I am the CTO at Zen. I'm responsible for the architecture and all that stuff. I'm also from a mathematics background, as well as Ash. I have been in Israel for a while. I've been in Bitcoin for a while. I'm interested in decentralized platforms, and that's about it.
Okay, so guys, thank you very much for the interview. I hope the sound comes out well enough so you can hear it on YouTube video. I will put it online. I cannot promise anything, but it was interesting, and maybe we'll see each other again.
All right, thank you very much.
Thanks so much.
Take care.